Hey there, and welcome back to Digital Dimension. It's great to see you again. I hope you've had a chance to practice what we covered in our last video on conditional statements, if, else, and elif. If you have any questions or ran into any challenges, feel free to drop them in the comments below. We're here to help. Today, we're going to dive into a powerful concept that will make your coding even more efficient, loops. But before we get too far into that, let's do a quick recap of what we learned last time. In our last video, we explored the fundamentals of making decisions in your code using conditional statements. We started with the if statement, which allows your program to execute certain code only when a specific condition is true. We then looked at else, which handles what happens when that condition isn't met, and elif, which gives you even more control by allowing multiple conditions to be checked in sequence. We also talked about logical operators like and, or, and not, which help you combine multiple conditions into a single statement. For instance, and ensures that all conditions are true, while or checks if at least one condition is true, and not inverts a condition. These operators make our code more flexible and powerful. Additionally, we touched on the importance of understanding the difference between one single equal for assignment and two equals for comparison, as well as how to use indentation properly to keep your code clean and functional. These concepts form the foundation for more complex logic in your programs, and they'll be very helpful as we dive into loops today. If you haven't watched last week's video yet, I highly recommend checking it out and taking the quiz at the end to test your knowledge. Now, let's quickly go over the answers to last week's quiz. Scenario 1. You want to check if it's both sunny and warm before deciding to go outside. The correct statement is, if is sunny and is warm. This checks that both conditions are true before executing the code inside the if block. You might recall from the last video that we initially used is sunny equal true to explicitly check if is sunny is true. This works, but Python allows us to be more concise. Writing if is sunny is implicitly asking is sunny true. Python automatically understands that we're checking for truthiness. Similarly, if is sunny and is warm is asking if both conditions are true. This is the preferred way to write it in Python, because it's cleaner and more readable. Scenario 2. You're deciding what to wear based on the weather. The correct approach is to use the following structure. This structure correctly handles all possible conditions by using if, elif, and else statements, so the correct answer would be all the above. Scenario 3. You want to sleep in only if it's the weekend or a holiday. The correct conditional statement is if is weekend or is holiday. This checks if either condition is true, allowing you to sleep in on either the weekend or a holiday. Great job if you got those right. If you didn't, review the video or do some research online. These quizzes are a fantastic way to reinforce your understanding of these concepts. Now that we've refreshed our memories, let's talk about what's in store for today. Imagine having a repetitive task, like sending out a bunch of invitations. Wouldn't it be nice if you could automate that? That's where loops come in. Loops in Python allow you to repeat a block of code multiple times, without having to write it out each time. We'll be exploring two types of loops: for loops, which are perfect for when you know exactly how many times you need to repeat something, and while loops, which keep going as long as a condition is true. By the end of this video, you'll be able to automate repetitive tasks in your code, making your programs more efficient and powerful. Last time, we saw how if statements could help us make decisions based on conditions. But what if you need to repeat an action for each item in a sequence? That's where for loops come in. To start, let's use something simple like a string. Imagine you want to look at each letter in a word or a sentence. A for loop can help you do that efficiently. Here's an example where we iterate over the word Python and print each letter on a new line. Notice how the loop goes through each character in the string, doing the work with just a few lines of code. We can even use string methods. Do you remember those? For example, we can use upper to make the letters that come out of our for loop uppercase. This is a great way to combine what we've learned about strings with the power of loops to manipulate and work with text in a more dynamic way. Here's the code example for your script. Just like how we structure conditions with if, For loops follow a clear, logical pattern that makes repetitive tasks easy and straightforward. And don't forget to indent. Are you starting to understand what a for loop does? It goes over every letter in a string, in this example, but it can do much more. Sometimes you may need to repeat an action a specific number of times, and this is where range comes in handy. The range function generates a sequence of numbers which we can use in a for loop. Let's take a look at a practical example, printing something a certain number of times. Imagine you want to print a word like party several times. You can use a for loop along with the range function to do this. In this case, range 5 generates a sequence of numbers from 0 to 4. The loop will run 5 times, once for each number in that sequence, and it will print party 5 times. Try it out and see what happens. Let's quickly remind ourselves about something we discussed before, how programming languages like Python often start counting from 0 instead of 1, so when you use range 5, the sequence starts at 0 and ends at 4, even though we think of it as counting 5 times. This is an important concept to keep in mind, as it's common in many programming languages. Let's break down the range function. It can take up to 3 arguments. First, we have start, which is the number where the sequence begins. It is optional, and if it's left empty, it defaults to 0. Stop, which is the number where the sequence ends. Attention, because it doesn't include this number. And step, which is the difference between each number in the sequence. It is optional, and if it's left empty, it defaults to 1. For now, we're only using one argument, 5, which tells the loop to repeat 5 times. Each time the for loop runs, it executes the print function and prints party. Let's take a look at a more detailed example by creating a countdown. This is a great way to explore how we can use more arguments with the range function. By using range 10, 0 minus 1, we can set our loop to count down from 10 to 1. In this case, range tells Python to start at 10, stop before reaching 0, and step down by minus 1 with each iteration. This allows the loop to count down from 10 to 1. Each time the for loop prints the current value of I, showing the countdown. Run the code and see for yourself. Let's break down the arguments we used in range. For start, which is where the loop begins, we use 10. In stop, which is where the loop stops, we use 0. But remember, Python stops one step before the stop value, so in this case, it stops before 0. And then step, that controls how much to increase or decrease each time the loop runs. Here, we're using minus 1 to count down by 1 with each iteration. You might have noticed that we use the letter I in both of our examples, but what exactly is I? In a for loop, I is just a variable name, short for iterator or index, that takes on the value of each number in the sequence generated by range. In our first example, I went from 0 to 4 because we used range 5. In the countdown example, I went from 10 to 1 because we used range 10, 0, minus 1. Do you remember when we iterated over the word Python? We used letter instead of I there, so we already had a more descriptive name for that variable. So each cycle of the loop, I, in that case letter, was a letter from our word. Each time the loop runs, Python assigns the next value in the sequence to I, and then the code inside the loop is executed. You don't have to use I, you can use any variable name you like we used letter in the Python word example. For instance, we could write, in this case, we've named our variable number instead of I. It works exactly the same, but sometimes choosing a more descriptive variable name makes your code easier to understand. However, you'll often see I used as a default variable in loop, especially when the variable name doesn't need to be descriptive for the task at hand. I stands for iterator, and it's a common shorthand. Now let's make our program a bit more interactive by using the input function to control how many times the loop runs. First, we prompt the user to enter a number. Do you remember how to do it? Create a variable and assign input to it. Just a quick reminder, we need the output of this input to be a number. Do you remember what we need to do in this case? That's right, wrap input with int, so we get an integer. Then we use the range function in our for loop to repeat the action as many times as the user requested. Here's an example. This integration between loops and other Python features like input makes your code dynamic and responsive to what the user wants. With just a few lines of code, you can create programs that react based on the user input. And it's also great for you to play around with different Python features. Join them together, make mistakes, and learn more about those mistakes. Remember, mistakes are the way to move. Each error helps you improve. Now I want to remind you that it's completely normal to feel like there's a lot to take in. Python is powerful, but learning it step by step will make everything clearer. And that's why I'm going to split this topic into 3 parts. I don't want to overwhelm you with too much information in one go, so for this week we'll stop here, but don't worry. Next week we'll dive even deeper. In part 2, we'll explore the power of while loops and learn how they work differently from for loops. We'll also combine for loops with conditional statements to add more flexibility to our code and compare the strengths of both loop types for different tasks. In the meantime, keep practicing what we've covered today. Play around with for loops, experiment with different ranges, and don't be afraid to make mistakes. That's how you learn and grow as a programmer. Be sure you feel comfortable with these concepts before moving on. Thanks for watching, until next week for more Python adventures. Keep coding, and I'll see you in the next dimension.